Welcome to this video on finding maximums and minimums of polynomial functions. Our first example is going to be the function f of x equals x squared minus 4x plus 3, and we want to find the maximum or minimum value. So first, how do we tell if we're going to have a maximum or minimum value, aside from the question telling us which one we're going to have? And that comes from the leading coefficient, which is the coefficient in front of the x term. So since this is positive, it's a positive 1 here, that means our parabola is going to open up. If it was negative, it would open down. So positive leading coefficient, negative leading coefficient. The other way that that number is referred to is by the letter associated with your generic quadratic, and that is ax squared plus bx plus c. So a is your leading coefficient, and so positive a opens up, negative a opens down. So looking at a positive parabola, since you can only get a minimum value, that's where you'll have minimums, because the maximum goes on forever in the positive direction. A negative a, you get a maximum value because it goes on forever in the negative direction but stops in the positive direction. So if we were to graph this, we would get f of x, we'd get this parabola here for the f of x, and you could get here the value off of the graph, because this one is a nice number. It is 2, -1, so the minimum value is -1. But what if we didn't want to graph it, or it was not coming out to a nice number, an integer? Then we could use the formula to find the maximum is x equals -b over 2a. And those b's and a's refer to the coefficients in the quadratic. So -b, so we're going to take negative of the linear term, which is the number in front of x, and divide that by 2 times the coefficient of the quadratic term, or the x squared. So this will give me 2. Then I'm going to find the y value. I'm going to substitute that back into the f of x equation, and I would get 2 squared minus 4 times 2 plus 3. And that simplifies to 4 minus 8 plus 3, which is, as we suspected from the graph, -1. So the minimum value of this function is -1. Now we're going to apply this to some application problems. Our first example is a little abstract because it's just find the numbers. So we want to find two numbers whose sum is 20, and we want to find their maximum possible product. All right, so we got x, we know their sum is 20, and we know if we multiply them together, we would get the product. But obviously we don't want two variables, so I'm going to use a system of equations to get this to be one variable. And I'm just going to say y equals 20 minus x. And that means the product then, x times 20 minus x, which now gives us a quadratic. And this matches what the question says, which asks for a maximum, and we have a negative quadratic term, which means our parabola is opening down, which means we do indeed have a maximum in this problem. And now it's just using our x equals -b over 2a. So we're going to do -20 over 2 times -1. That gives us 10. And looking here at y, if x is 10, y is 20 minus 10, or also 10. So the maximum possible product is 10 times 10, which is 100. All right, so that's your just find the number problems. The next two problems are more real-world application. The first is with all the staying at home we're doing, everybody's making gardens. So let's say you found in your shed you had 100 meters of fencing that you're going to use to make a garden, and you want to maximize, you want to find the greatest possible area for your garden. But you happen to have a stone wall on your property that you're going to use as a fourth side so that you only have to have 3 sides for your garden. All right, so let me draw that in. So we got this lovely 3-sided rectangle with our stone wall as the fourth side. Okay, so I'm going to just say, I don't know how long that is, but we'll call it X. Then I know since this is a rectangle, this side will be X as well. And since I have 100 meters of fencing, if I subtract how much I use for those 2 sides, which are 2x, I can use whatever is left for my third side. Now we want to maximize the area, so that's the formula we're going to use, length times width. So it's going to be x times 100 minus 2x. And we get our quadratic again with a negative leading coefficient, which means we are having a maximum. I take out the negative b over 2a. So let's see, I get a negative 100 over 2 times negative 2, and that gives me 25. So if I look over back at my picture, each of these sides is 25, and if I substitute 25 in for x, this side is 50. So that means our maximum area is 25 times 50, and that is 1,250 meters squared. Now you might have noticed that this question also asks for finding the domain. And so domain, remember, is all the possible inputs into your function. If you were just looking at this as a pure mathematical function, 100x minus 2x squared, then it's all reals. But since we have an application where it's making a rectangle, we can't have negative sides and we can't have a side of 0. So the lower bound of our domain is that this side here can't equal 0. So that would just be when x is 0. And we have a parenthesis because we don't want to include 0 because then we wouldn't have any width to our garden. Then the other part of the domain is 100 minus 2x can't equal 0. So basically it has to be greater than 0. So that means 100 has to be greater than 2x. So x has to be less than 50. So that's the other end of our domain. Because anything outside of that would give us negative numbers, and if we were 0 or 50, we'd get 0. And you can't make a rectangle out of negative numbers or 0. All right, our last example is we're working for a bike rental company, and this is probably the hardest one just conceptually sometimes to set up the formula. So we charge $10 a day and average 30 rentals per day. So we want to determine if we increase our rental charge by $1, we have found that we lose 2 rentals. So we want to figure out what price would give us a maximum income. What can be helpful if you get a situation which you're not familiar with is to write out the formula just in words of what you're looking for. So income, not profit, because that's a whole different can of worms. just the amount of money the company would take in would be number of rentals times the price to rent them. So now let's take our information from the question. We start with 30 rentals a day. That's our starting point when we charge $10. But we've noticed that if we increase by increments of 1, then our rentals go down by increments of 2. So like if X equaled 1, our number of rentals go down by 2. If X equaled 2, our number of rentals go down by 4. If X equals 3, our number of rentals go down by 6. So that's where this comes from. Now we just need to FOIL this out. So you get 300 plus 10x minus 2x squared. Now we use our negative b over 2a. And that gives us negative 10 over 2 times negative 2, which is 2.5. Now we don't want to just substitute this back into the 300 plus 10x minus 2x squared, because this question asks for something different. It asks for what price should I be charged. And the price is this parenthesis right there. So all I care about is that price equals 10 plus x. So that's going to equal 10 plus 2.5, or $12.50 is the price you should charge. That would give you the maximum income. Now, since you can't do half a rental, you would have to decide which way you wanted to go to for the price. Probably the 2 would be more appealing, so a price of $12 would be more appealing to people than a price of $13. All right, so that is the end of the slides. I hope this helps, and I'll see you in the next video.